Hi children, in today's class we discuss about three-dimensional geometry, under that the straight lines. So to do the straight lines or for learning the concepts of straight lines, we need the basic things from the previous chapter, vectors. So let me begin with the basic concepts of the vectors, then we will proceed to the straight lines. So basic concepts, what basic concepts are required to study straight lines? The basic concepts are, first one is position vector of a point. What is the position vector of a point? Position vector of a point, position vector of a point is a vector whose initial point is origin and terminal point is nothing but the given point. So is a vector whose initial point is the origin and terminal point is the given point. So such vectors are called as position vectors. So let me write, let P of x comma y comma z be any point in space. Then position vector of P. Whenever we say that position vector of P, it is with respect to origin only. Position vector of P with respect to origin. Or in other words, a vector whose initial point is 0 and terminal point is the given point. So the position vector of P with respect to origin is OP and is denoted by small r. So this is denoted by the vector small r, which can be written as xi plus yj plus zk. In this, again, we have the magnitude. So the magnitude of r is equals to under root x squared plus y squared plus z squared. The second one is, what are the direction ratios? Direction ratios of vector r. Direction ratios of vector r, or direction ratios of the line OP. In vectors, we have studied as a vector. Now we are going to study about the line. Whether you take the vector or you take the line OP, then the direction ratios of OP are x minus 0, y minus 0, z minus 0, or we can write it as or x comma y comma z. Then what are the direction cosines? Direction cosines of r. Direction cosines are x by magnitude of r. That means the length of this. Direction ratio by the length of OP or magnitude of OP. X by magnitude of r. Y by magnitude of r. Z by magnitude of r. So I hope this point is clear about the position vector. How to write the position vector means it is always with respect to the origin. Then what are the drs of the position vector? What are the direction cosines of the position vector? Then how do you find the magnitude? Next, second point is a vector passing through 2 points. A vector passing through 2 points A of x1, y1, z1 and b of x2, y2, z2. How it will be? Suppose if you draw three-dimensional, there is a point A of x1, y1, z1 and another point B of x2, y2, z2. Then a vector passing through AB, vector passing through the points AB is denoted by AB upon that arrow mark. So A vector passing through 2 points A and B is AB is equals to, how do you write the vector from the chapter vectors? Is nothing but x2 minus x1 into I cap plus y2 minus y1 into j cap plus z2 minus z1 into k cap. So from this, magnitude of AB is equals to under root x2 minus x1 whole square plus y2 minus y1 whole square plus z2 minus z1 whole square. Then what are the drs? Drs of vector AB or line AB or x2 minus x1 comma y2 minus y1 comma z2 minus z1. They are the direction ratios. Next, what are the direction cosines? Direction cosines of AB are x2 minus x1 by magnitude of AB comma y2 minus y1 by magnitude of AB comma z2 minus z1 by magnitude of AB. So this is about the position vectors, magnitudes, direction ratio, direction cosines. The next one is vector passing through any 2 points. Then for that, how to find the magnitude and how to find layers and how to find bases. These are the 2 basic concepts. Next. Next, third basic concept is a unit vector in the direction of A. A unit vector in the direction of given vector A is A cap. How do you find this? You can find the unit vector by vector A by its magnitude. Next, fourth point is a vector, or you can write unit vector, a unit vector in the direction of given vector A and having magnitude lambda is. So you are finding the unit vector in the direction of A and having the magnitude lambda is lambda into A cap. Next, fifth one is the dot product and cross product. So let me revise dot product because cross product we are not going to use. So let me complete the dot product or scalar product. Dot product or scalar product. Under this, scalar product. So under this, first one is, how do you define dot product? A dot B is equals to magnitude of A, magnitude of B, cos theta. And second one is cos theta, you are finding as A dot B by magnitude of A into magnitude of B. Next, the third one is, if A is equals to A1i plus A2j plus A3k and B is equals to B1i plus B2j plus B3k, then A dot B. How do you write A dot B? A dot B is equals to A1b1 plus A2b2 plus A3b3. Next, fourth one is A dot A is equals to magnitude 1. These are all we have seen already. Next, fifth one is if theta is equals to 90 degrees. That means if A is perpendicular to B, if A is perpendicular to B, then A dot B will be equals to 90 degrees. A dot B will be equals to 0. A dot B will be equals to 0, or A1, A2, A1, this is, sorry, not A1, A2, A1 into B1, just you see here, A dot B, A1, B1 plus A2, B2 plus A3, B3 is equals to 0. So, this is about dot product. Am I right? So, based on this basic concepts, we have to do the concepts and problems in the straight line. Next, here what important is how do you find the angle between? So, you have to make use of how to find the angle between them. Next, when Cartesian A dot B, how do you find? Next, if there are two lines are perpendicular to each other, you have to make use of this concept. So that's why I am revising this. Next, last one is vector product. In that small things let we use. Then we will go to the straight lines. The last concept is vector product or cross product. So how did you define A cross B is equals to magnitude of A, magnitude of B, sine theta into n cap. Now in this, if at all you wanted to find out sine theta, that is magnitude of A cross B by magnitude of A into magnitude of B. Next, third one is if theta is equals to 0. If theta is equals to 0, then A cross B, theta is equals to 0 means vector A is parallel to B, which implies A cross B. When theta is 0, A cross B will be equals to 0. When A cross B is 0, then we say that A is parallel to B. Next, fourth one is A cross A. When you put A cross A, so A cross A, the angle will be 0. When the angle is 0, this totally becomes 0. A cross A is equals to 0, which implies I cross I, J cross J, K cross K will be equals to 0. Next, fifth point. If A is equals to A1I plus A2J plus A3K and B is equals to B1I plus B2J plus B3K, then A cross B you are finding by using the determinants, that is I, J, K, A1, A2, A3, B1, B2, B3. So this is the way you are finding the cross product of two vectors. Next, now collinearity of vectors. This is fundamental thing. That's why I am not considering. But even then, if required, then how to? So I am writing once again the collinearity of vectors. Two vectors A and B are collinear if A is equals to lambda B. One vector, if you can able to express in terms of the other vector, then we call both the vectors are collinear vectors. That is, if A is equals to A1I plus A2J plus A3K and B is equals to B1I plus B2J plus B3K, then is parallel to B. A is parallel to B, or A and B are collinear. In A is parallel to B implies this vector is proportional to that vector, means corresponding components. Now you can see here A1 is equals to lambda B1, A2 is equals to lambda B2, A3 is equals to lambda B3. When you take the proportion, A1 by B1 is equals to lambda is equals to A2 by B2, that is also equals to lambda, A3 by B3, that is also equals to lambda, A2 by B2, that is equals to A3 by B3. Whenever you wanted to show two vectors are parallel or two lines are parallel, two vectors are parallel or two lines are parallel, we show that A is equals to lambda B, or the corresponding components ratio will be the same. A1 by B1, A2 by B2, A3 by B3 will be the same. So I hope this is clear. This is all about the basic things which we require for doing straight lines. Now come to the straight lines. Straight line is a straight line is uniquely determined if first one is when line passing through a point and parallel to the vector and given vector, whatever you call, and parallel to a given vector. When these two are given, straight line is defined, that is passing through a point and parallel to a given vector, passing through a point and parallel to a given vector, then the straight line is determined. Or 2 points are given in space, then also straight line will be determined. So in these two cases, straight lines will be determined or straight lines can be defined. Now the major thing what I say, whenever straight lines are there, keep in mind that we need one point and we need a parallel vector, that's all. So given parallel to a, so I have replied positive point and parallel to a given vector. Okay. So straight line means, remember that it should pass through a point and it must be parallel to a vector. If these 2 points are known, straight lines is over. So let me derive the first equation. So first one is so there is a point A of x1, y1, z1. So the line L is a passing through the point A whose position vector is A. Let P be any point. Let P of x, y, z be any point on that line such that whose position vector is R. And line L is parallel to a vector B. This much only given. Then how do you find out the equation of a line L? So this is line L. So let me write, let the line L passing through A of x1, y1, z1 whose position vector is A and The line is passing through a point A and parallel to the vector B, whose direction ratios are A, B, C. So this is a line passing through this point whose position vector is A and parallel to the vector B. This vector drs are nothing but A, B, C. Let P of x, y, z be any point on line L whose position vector is R. That's all only. Passing through a point parallel to the vector. Now you take P is any point, then the derivation is very simple. So when a line is passing through 2 points, you know how to find out the vector passing through the 2 points. Therefore, the vector passing through 2 points is nothing but AP. Now the vector AB is parallel to vector B. When vector is parallel to another vector, we write as when vector A is equals to lambda times of the other vector. First vector is equals to lambda times of the other vector. So let me use the same concept here also. From figure, when 2 points are there, we know how to find out the vector, that is AP. How it is? This AP, because line is parallel to this, vector is also parallel to this, AP is parallel to B, which implies AP is equals to lambda times of B. What is AP? AP is nothing but R minus A, that is OP minus OA. OP minus OA. So OP is R, OA is equals to A, which implies R minus A is equals to lambda B, or R is equals to A plus lambda B. So which is the required equation of a line in vector form. So which is required equation of a line in vector form. Now for every equation we have to find in vector form as well as in the Cartesian form. So this vector form we have found. Now let me do Cartesian form. Now Cartesian form. The equation of a line is R minus A is equals to lambda B. R is equals to what? X I plus Y J plus Z K. Am I right? R is nothing but Xi plus Yj plus Zk minus A is x1i plus y1j plus z1k is equals to lambda times of vector B, whose drs are nothing but ABC. Therefore, this is nothing but AI plus BJ plus CK, which implies x minus x1 into I plus y minus y1 into j plus z minus z1 into k is equals to lambda A into I, lambda B into j plus lambda c into k. When two vectors are equal, their corresponding components are equal, which implies x minus x1 is equals to lambda A, y minus y1 is equals to lambda B, z minus z1 is equals to lambda c. So from this, x minus x1 by A is equals to lambda, y minus y1 by B is equals to lambda, z minus z1 by C is equals to lambda. So x minus x1 by A is equals to y minus y1 by B is equals to z minus z1 by C is equals to some constant, whatever it may be. So which is the equation of a line in Cartesian form, which is required equation of a line in Cartesian form. I hope it is clear. So once again let me brief it. If a line is passing through a point and parallel to a vector, then we consider any general point whose position vector is odd. Then how to trace the equation? So when 2 points are there, you can find a vector, that is AP, which is parallel to B. Just I am writing AP is parallel to B. AP I can write it as R minus A, that is equal to lambda B, which is nothing but the required equation of a line. Then how do you bring into Cartesian form? That is very simple. Write the position vectors. R, the position vector of R is xi plus yz plus zk. Position vector of A is nothing but x1i plus y1j plus z1k. Then the vector B, already when the drs are known, like this, drs are known. When the drs are known, the vector B is nothing but ai plus bj plus ck. Just substitute and derive this equation. So I hope this is clear about the first derivation. Next, come to the second derivation. The next concept is a straight line passing through any 2 points. Previous one is passing through a single point and parallel to a given vector. The second concept is passing through 2 points. When it is passing through 2 points, I said straight line means passing through a point and parallel vector. That's all only we need it. Now here, passing through a point. So 2 points are there. You can take any one point. A, I will take it as A. But I need a parallel vector. How do I get a parallel vector? Parallel vector is not given. When parallel vector is not given, you can find parallel vector by using this only. How do you find the parallel vector? Take the vector AB. Take the vector AB. And here P is any general point. Like the previous one, you can take AP is another vector. Both the vectors are lying on the same straight line. Therefore, they are parallel to each other. Therefore, AP is parallel to AB. That's all like previous one. A line passing through a point. So one point is required. So I am taking as A. So the vector is AP. Parallel vector we don't have specially parallel vector, but 2 points are given. When 2 points are given, consider the vector AB. So AB and AB are lying on the same straight line. Therefore, AP will be parallel to AB. That's all. Proof is over. Given line, or you can write 2-point form. Heading 2 points form. Given line L passes through A of x1, y1, z1 and B of x2, y2, z2 whose position vectors are A and B. Let P of x comma y comma z be any point on line L, any point on line L whose position vector is R. From figure AP is parallel to AB because straight line means point and one parallel vector. So I am considering AB as parallel vector. AP is parallel to AB, which implies AP is equals to lambda times of AB, which implies R minus A is equals to lambda times of B minus A, or R is equals to A plus lambda times of B minus A, which is required equation of a line in vector form. Now you have to find it same thing in Cartesian form also. So Cartesian form. You can name it as star. For star implies, what is star? You just substitute position vectors xi plus yj plus zk minus a is x1i plus y1j plus z1k is equals to lambda times of x2i plus y2j plus z2k minus x1i plus y1j plus z1k. Am I right? B means x2i, y2j plus z2k. A means x1i plus y1j plus z1k. Just to simplify this is x minus x1 into I plus y minus y1 into j plus z minus z1 into k is equals to lambda times of x2 minus x1 into I plus lambda times of y2 minus y1 into j plus lambda times of z2 minus z1 into k, which implies now when two vectors are equal, their corresponding components are equal. So x minus x1 is equals to lambda times of x2 minus x1, y minus y1 is equals to lambda times of y2 minus y1, z minus z1 is equals to lambda times of z2 minus z1, which implies ratio, when you take all the ratios, becomes to lambda only. Therefore, x minus x1 by x2 minus x1, y minus y1 by y2 minus y1, z minus z1 by z2 minus z1 is equals to lambda. So, which is the required equation of a line in Cartesian form, which is required equation of a line in Cartesian form. So I hope this is clear. We are having only two formulae in the straight line. One is passing through a point parallel to a vector, that is r is equals to a plus lambda b. R is equals to a plus lambda b. Or in the Cartesian form, x minus x1 by a is equals to y minus y1 by b is equals to z minus z1 by c. If 2 points are given, then in the vector form, r is equals to a plus lambda into b minus a, or in Cartesian form, x minus x1 by x2 minus x1, y minus y1 by y2 minus y1, z minus z1 by z2 minus z1. Either you can remember the concept or straight away you can remember the formula. That is up to you. Whichever is easy for you. If you can able to remember this, you try to remember. Otherwise, just remember the formula. That is more than enough. These are the equations of the lines determined in two different ways. Next, come to how do you find the angle between the two lines. Next concept is, you can take as 3, angle between two lines. Vector form, Cartesian form. So, vector form. Let the equations of two lines are r is equals to a1 plus lambda b1 and r is equals to a2 plus mu b2. These are the, because r is equals to a plus lambda b is the equation of a line. Now I am taking two vectors. So here position vector, this is 1 and this is 2. What is the position vector and what is the parallel vector? So for one position vector of point is a1 and parallel vector is b1. Parallel vector is b1, and here for equation 2, position vector of point is A2. This is the position vector of the point, and parallel vector is B2. You should be able to identify what is the position vector of a point, what is the parallel vector, what is the position vector and what is the parallel vector. So you should be able to identify. That's why I am writing here. Then cos theta, finding the angle. Cos theta is equals to, whenever you are finding the angle between the two lines, you have to find out the angle between the parallel vectors only. That is, cos theta is equals to b1 dot b2 by magnitude of b1 into magnitude of b2, like vectors. How you are finding in vectors? A dot b by magnitude of a into magnitude of b. Here also same thing. b1 dot b2 by magnitude of b1 into magnitude of b2 is nothing but angle between two vectors. Next, Cartesian form. In Cartesian form, given two lines are x minus x1 by a1 is equals to y minus y1 by b1 is equals to z minus z1 by c1, and x minus a2 by a2 is equals to y minus y2 by b2 is equals to z minus z2 by c2. Then we don't want what are the coordinates of the point. We need only parallel vector. That means we need only the drs of the parallel vector. Then drs of parallel vectors are, for the first line, drs of this line, drs of the parallel vector of this line are a1, b1, c1, and for the second line, drs are a2, b2, c2. You should be able to identify. How do you find the drs of the parallel vector of this line? Is nothing but in the denominator, provided it is in the standard format. What is the standard format? X minus x1 by, y minus y1 by, z minus z1 by. Then the denominator, whatever is there, they are nothing but drs of the parallel vector. Then cos theta is equals to, you can write it as a1 a2 plus b1 b2 plus c1 c2 by under root a1 square plus b1 square plus c1 square into a2 square plus b2 square plus c2 square. So this I am not writing anything new. In the vectors only we have studied how to do the dot product. So the same thing I am repeating. Next, note. If the angle between the two lines, if theta is equals to 90 degrees, then automatically b1 dot b2 is equals to 0. So then the dot product is equals to 0. Or a1 a2 plus b1 b2 plus c1 c2 is equals to 0. Second one, if two lines are parallel, theta is equal to 90 degrees or L1 is perpendicular to L2. Next, if L1 is parallel to L2, when they are parallel, you can write as this vectors b1 is equals to lambda times of b2. b1 is equals to lambda times of b2, or the ratio of these two direction ratios, or a1 by a2 is equals to b1 by b2 is equals to c1 by c2. This also we have seen in vectors only. When they are perpendicular, their dot product is 0. B1 dot B2 is equals to 0. Or here numerator A1 A2 plus B1 B2 plus C1 C2 is equals to 0. If they are parallel, then one vector is expressed in terms of the other vector. That is B1 is equals to lambda times of B2. Or when you see the components, the ratio must be the same. That is, when you see this, A1 by A2 is equals to B1 by B2 is equals to C1 by C2. This is about the angle between the two lines. So that means angle between two lines means is nothing but angle between two parallel vectors. That's all only. Next concept is shortest distance between two skew lines. What do you mean by skew lines? The lines which neither intersect nor parallel. Now you can see in a plane, if you take in a plane, if you draw two lines, either they will be parallel or they will be intersecting in a plane. When you take the space, if you consider two lines like this, these two lines will never intersect and they never be parallel. Such kind of lines are called as skew lines. The lines which are neither intersecting nor parallel are called as skew lines. Now for such kind of lines, how do you find out the shortest distance? This shortest distance you have to find out. So for that, easiest way is go for vector form only. Don't go for the Cartesian form because that is very lengthy. So don't go for Cartesian. Whenever Cartesian is given also, try to bring it to vector form and try to finish off. Let R is equals to A1 plus lambda B1 and R is equals to A2 plus mu B2 or two skew lines. Then distance or shortest distance between these two lines, shortest distance between two lines is D is equals to, distance always it should be positive, therefore I am taking as modulus shortest distance. How do you write is A2 minus A1 dot B1 cross B2, A2 minus A1 dot product of B1 cross B2 by magnitude of B1 cross B2. So which gives, I am not deriving the formula because it takes a lot of time, so and we don't want derivation of this formula also. Directly you can take down the formula, that's all. So shortest distance between two skew lines is A2 minus A1 dot B1 cross B2 by magnitude of B1 cross B2. Now the last concept is, fifth one is shortest distance. So SD means shortest distance between two parallel lines. Parallel lines means the parallel vector will be the same. Two parallel lines. R is equals to A1 plus lambda B and R is equals to A2 plus mu B. Parallel lines, whenever they are parallel lines, the parallel vectors must be the same. You can notice here, parallel vectors must be the same. Is D is equals to A2 minus A1 cross B by magnitude of B. Since distance is positive, we take the modulus. So these are the 5 concepts under the straight line. So try to understand all this, then in the next video we go for the problems.